All right, first thing, a quick review. This was on the quiz yesterday. You guys have the ability to go from a polar coordinate to a rectangular coordinate. Yesterday, hopefully on the quiz, x was equal to r cosine theta, and y was equal to r sine theta. Now we're going to go in reverse. All right, I'm going to give you the rectangular, and you're going to give me the polar. It's a lot more work than just multiplying, unfortunately. All right, a lot more work. Before we start with the steps, take a look. When you write anything from rectangular to polar, the r value has to be positive, and the angle has to be not only positive, but it has to be in radians. Yes. So keep that in mind today. As we transform all these rectangulars into polars, the r value's got to be positive, angle's got to be positive, and a radian. All right? We ready to go? All right, first one. Give me a quick sketch. -2, 0. Throw that on a quick sketch of a rectangular graph. -2, 0. Look around in your groups. Make sure everyone's got it in the correct spot. -2, 0. Do a quick sketch here. Something like this, I don't need to tell you any steps. You should tell me already where that is on the polar graph. Ready? On the polar graph, r value's got to be positive, so I'm not going to put -2. 2. Hey, you guys know where this is on any graph I give you, rectangular or polar. What's this right here? 180, right? Which is the same as what? Pi. You just put it into polar. I don't need to show you any steps when it's on one of the axes. The problem is when it's in a quadrant now. Okay, everyone good right there? Any issues? There's 1 out of 3 already done. If it's on one of the axes, it's not a big deal. Just please make sure, regardless if the x-coordinate is negative or not, make sure your r value is positive always when you write it into polar. We all good? Now we ready to get a little tough? All right, let's do this. Now put into polar -1 radical 3. Big thing, I need you guys to know what quadrant we're in. I need you to know that. So if I go -1 radical 3, think about it. What quadrant would I be in on the rectangular grid here? -1, +3. 2. So now that you've identified the quadrant, draw a right triangle like we used to back in the day in that quadrant. So quadrant 2, there's my right triangle. Label the 2 legs with your coordinates. -1, is that an x or a y coordinate? That's an x, so it should go on the x-axis. But this is a side length. I'm not going to put -1. 1. I know I went in the negative direction. That just told me to go to the second quadrant, but a side length can't be negative. And what do you think I'm going to do with the radical 3? Put that on the other leg, radical 3. Everyone with me so far? Okay, define the r value in your polar coordinate. Define the r value. Here's your r value right here. That's your r value, the hypotenuse. So what do you think I'm going to do to find it? Pythagorean theorem. Okay, so to find your r value, we're going to do Pythagorean theorem. So radical 3 all squared plus 1 squared equals, you can put c if you want. I'm going to put r because that's what we're finding, r squared. That's your r in the polar grid. All right, keep helping me here. Radical 3 squared. 3 plus 1 equals r squared. R squared equals 4. What's the value of r and my polar coordinate now? 2. And you could argue with me plus or minus 2, but what did we say when you changed it? Always has to be positive. Okay, so R2. That's the easier part. Now we got to find the darn angle. We got to find theta. So here's what we need to do here. I need you guys to help me find what this angle is here, theta. Because remember, every polar coordinate comes in r theta. R we already found was 2. Now you're going to help me find the angle in quadrant 2. Here's how we're going to do it. You're going to use the side lengths of the triangle, and you're going to find this angle right here. What's this angle called? Give a special name to it. Yeah, what is it? Reference angle. You're going to find the reference angle. All right, by using the opposite and the adjacent side. Let me say that again. The opposite and the adjacent side. OA? Tangent. Yes, that's what we're going to use to find the reference angle. So everyone ready? Tangent of my reference angle, and you can put theta. I'm going to put, just so you guys know, I'm going to find the reference angle. What's the opposite side? Radical 3 over 1, okay. Anybody remember this is why you need the darn calculators? What I need to plug into the calculators now? Yes, inverse tangent, second inverse. So inverse tangent, radical 3 over 1. So get my good old fraction template, or you can just put radical 3, it's up to you. Radical 3 over 1. The reference angle is 60. Now, I don't know where you guys want to go from here now. Do you want to convert? Actually, I am going to have you do that. All right, I'm going to force you to do that. What's that in radians? Pi over 3. Is that my angle, though, that I'm looking for? What quadrant am I in? 2. 60 is not in quadrant 2. That's your reference angle right here. Your reference angle right here is pi over 3. How do I find the actual angle now? Oh, yep, here we go. What's this? Pi. So theta is going to be equal to pi. And what are you doing with the pi and the pi over 3? Adding or subtracting to get that angle? Adding or subtracting it? Subtracting it. So pi minus pi over 3. And we've done this a lot this unit. This is why I'm going to have you do it this way. What do you want to change the pi into? So I can subtract them. 3 pi over 3 minus pi over 3. What's that angle measure? So now put the two together. What's my polar coordinate? What was my r value? 2 comma 2 pi over 3. There is my polar coordinate. Now, am I going to mark you incorrect if you just kept 60, did 180 minus radians? No, I don't care how you do it. Okay, I don't care. All right, that's fine too. If you rather just wait to the end to convert, that's fine. All right, whatever floats your boat. We okay? We got one more. Bear down for one more. 3, -1. Where am I? That's the first thing you got to decide. Where are you? 3, -1. Quadrant 4. Make a triangle in quadrant 4. I should ask this before I move on. Are we okay on how to make the triangle? Okay, here you go. Here's what I used to teach kids. Make a bow tie. And then whatever quadrant you're in, that's what the triangle looks like. Okay, make a bow tie. That'll figure, and decide what quadrant you're in. That's what the triangle looks like. Okay. All right, 3. 3 is what coordinate? X coordinate, right? So it goes on the x-axis with my triangle. 3. -1's my y, but I leave the negatives out because I'm doing side length. So +1. Looks pretty good. All right, what's your R value? Let's find that first. Pythagorean theorem. 3 squared plus 1 squared equals that R value squared. 9 and 1. R squared equals 10. So the R value for the polar coordinate will be the square root of 10. Can you break 10 down? No, and this is the unfortunate news. Tomorrow you will have a couple where you need to break down if you can break it down. Okay, this one I can't though. So there's my R value. Are we ready to tackle the theta? Okay, so how do I find the reference angle? You're always going to use tangent. Don't think you're going to get fancy. Oh, let me use sine on this. No, just use tangent. Please just use tangent. So tangent of my reference angle will be equal to, what's the opposite side here? 1 over 3. Yep, 1 over 3. So go ahead right now. Inverse tangent, 1 over 3. And here's the rule we'll always abide by, round to the nearest degree. Okay, just round to the nearest degree. Okay, make it easy on ourselves. Nearest degree, what'd you guys have? 18 degrees. I convert right now. I'm going to convert it right now. Now, 18 isn't one of those special ones we know off the top of our domes here. Anybody remember how to convert it? Pi over 180. Yep, so multiply by pi over 180. Reduce 18 over 180 right now in your calculator. Reduce 18 over 180 to tell me what this is in radians. Pi over 10, yep. That's the reference angle. Pi over 10. How are you going to find the angle in quadrant 4 now? How do you find that angle? Help me. 2 pi now, because now I'm over here. So I'm going to take 2 pi and the reference angle, pi over 10. Add them or subtract them to get that angle. Here's 2 pi. I'm going to do what to these two? Subtract them. Can I get somebody's help? What do you want me to change 2 pi into? You guys are good. You guys are good. Believe. 20 pi over 10 minus pi over 10. That angle in radians, 19 pi over 10. So the coordinate will be radical 10, 19 pi over 10. Questions? Whew, wipe the sweat away. Everyone all right? Yes, go ahead. Say that. Am I going to have you graph these? No. Not right now. Not right now, no. Well, eventually, at the end of the unit, yes, you're going to have to graph these. Well, something like this, hey, something like this, no. That's ridiculous. No, if you're asking something like this, no. Okay. Anything else? Okay. We're good. 13 minutes, 14 minutes.